Hello, everyone. The Black Hills of South Dakota. Men once carved titans from granite, yet even this monument to permanence is, in geological terms, a mayfly. Water seeps into hairline cracks, freezes, expands, and ever so slowly pries apart the stone. Climbers return each summer, not to conquer, but to caulk, applying tiny beads of silicone to forestall the patient hand of frost. Even empires of stone must be maintained against the tireless chemistry of the planet. Weathering and erosion. Well, I will say, across span of eons, Earth is a sculptor and a saboteur. Tectonic forces lift mountains toward the heavens. Wind, water, and gravity tear them down again. This eternal cycle, weathering and erosion, is not destruction, but renewal. Rock is broken, transported, deposited, and reborn as new rock. It is the planet breathing in stone. Well, here at peaks and polar latitudes especially, where temperature swings are a lot, including like here in Minnesota, rocks split along invisible seams, joints as the pressure changes, entire domes exfoliate like sunburned skin, each sheet peeling away to reveal a younger, paler surface beneath. In Yellowstone, Half Dome gleams under the slow motion, shedding an earthly onion, layer upon layer, forever revealing itself. Exfoliation sheets. So, when you're talking about you're going to exfoliate your face, similar thing because it's a rounded shape, right? Rounded. Exfoliation sheets are rounded. You could see an example even in a boulder. Frost wedging. We get a lot of that in Minnesota as well. See some frost wedging. One winter's night, a drop of water slips into a rock, it freezes, it expands, it pries the rock apart. Repeat this for 10,000 years, and mountains crumble to gravel. Elsewhere in deserts along coast, crystals of salt swell in pores, honeycombing the stone into fantastical, well, do we got a picture? Well, not fantastical. What happens in these little cracks? Lizards find shade. In the forests, the weathering has happened by, trees and vegetation, right? All these things are just kind of weathering the world and breaking things down, right? Patient, persistent. They insinuate themselves into fractures using the slow hydraulics of growth to split boulders like wedges of cheese. Chemical weathering. Again, more weathering. If physical weathering is a brute force, chemical weathering is more of a slower process, right? Water and air whisper to minerals, altering their very identity. Oxygen turns iron to rust. Carbonic acid dissolves limestone into nothingness. In warm, low wetlands, rocks meet and melt. At least they look like they're melting in the process. The more rock is fractured, the more surface there is for that same chemistry to do its magic. Proof that even in decay, complexity breeds opportunity. I just talked about this. The process of rust. In this process, sharp corners are rounded off, blocks become spheres. A granite boulder that once jetted from the earth now resembles an egg, waiting to hatch. Not all minerals weather equally, of course. Some, like quartz, endure, becoming the sand beneath our feet. In this way, beaches are kind of cemeteries of the continents, right? The ghosts of vanished mountains rolling endlessly in the surf. Spherical weathering, in a nutshell, the more moisture there is in the climate, the more spherical the weathering is. More landforms created by weathering. These ones mostly wind. Wind has more of an erosive force in the deserts. Karst landforms. I showed you some examples of this type of thing earlier. Basically, limestone gets dissolved away, but then it also rebuilds elsewhere. I would say these are areas that you get a lot of weathering underground, and so you can get sinkholes and stuff like that. And of course, these sinkholes, usually they're on the news if they're under like a road or a house, right? But, very often we don't hear about it because it'll be kind of like not out in the middle of nowhere, but out in the middle of nowhere. You see the slow process of water basically just dissolving the rock until you get a cave in. This is underwater if you like diving. Belize, the Great Blue Hole. I have actually scuba dived there. It's pretty cool. You just go straight down and it gets darker and darker until you get to the bottom, where sometimes it can be pitch black depending on what weather is like that day. Disappearing streams, actually in Belize, if you ever went tubing down a river, we went tubing, but the river goes underground, and there was enough room to breathe and everything, so it was still fun. We all had low flashlights, but something I'd recommend. Again, I did that mostly in Belize, but other countries have that as well. A bit more of the karst landscapes. Nowhere is rock's mortality more dramatic than in karst landscapes. Beneath our feet, rainwater, slightly acidic, yet restless, eats away at limestone, opening up chasms and caverns. Sinkholes collapse like a sudden blink of a wary eye. Rivers vanish into the underworld, reappearing miles away. In China, actually, I did a lot of these in China as well. And the land itself rises in jagged towers, remnants of stone dissolved and drained. Let's see, I think, here's some pictures of kind of like how the towers look. And the limestone reforms into, these different structures that are in caves. Again, examples of caves, what the streams look like that they're connected to. This is actually some of the karst landscapes. Last time I was in China, went on a nice long bike ride. I would say you probably will see landscapes like this if you watch a movie about the Vietnam War. You'll see much more of this kind of thing, these types of landscapes. And then this was us going caving. Again, these are stalagmites and stalactites, right, in columns. These are all recreated underground from the same limestone process. And I would say, if you've been to caves, maybe you've been to some in Colorado or something, kind of depends. These ones I went to in China were kind of newly discovered, and so, there wasn't a lot of damage to them, which you can see in lots of older caves. Ground's very slippery, because that limestone residue is all over the ground. It's just like very muddy. As you can see, there wasn't really infrastructure or anything. If you go to caves in the US, there'll be steps and ladders and things, but this was a pretty new cave. Didn't have a lot of rules and regulations. Probably was very unsafe when it comes down to it. This was when we went inner tubing. This was kind of like our little raft that we went on. Couldn't really get pictures of the underwater streams, unfortunately. It was just too dark. And so, this is about as good as it could get. but at the end, that water is all very, very muddy, right? And it has so much limestone dissolved in it that it's tough to sink. You try to push yourself under the water and you'll just keep on rising to the top. This is just us washing off afterwards. And then we had scorpions on a stick afterward for dinner. Stalagmites, stalactites, a little bit of an image about how that all happens, how it comes about. Mass movement. Let's see if I got some good picture examples. Mass movement. Well, in a nutshell, gravity, right? Gravity is always pulling on everything. It's kind of like pulling us all down, wearing us all down. Just about the steeper the angle of something, right? The more it'll be collapsing down, right? And these angles can kind of change through time. I'm not going to go through every single type of factor of mass movement. I think I got some pictures of this stuff, though. Oh, yes. Soil creep. Sounds like a guy you met at a bar you can't get away from. Soil creep. That is, well, if you see anything that is on a hill, keep in mind that that hill is slowly kind of moving down. In this process, it's going to be very slow, but it happens. It happens, right? And we can see it on the landscape all over us, Gravity is a great equalizer. It weights, and when the balance between friction and weight is broken, the world moves. Soil creeps, trees lean, slopes slump, like tired shoulders. In wetter places, the land flows, much more rapidly. Mudslides, debris flows. In an instant, that's solidity, we realize, is an illusion. Especially places that have had deforestation. If those tree roots, if you cut down the tree roots die. Lots of places the roots are kind of holding everything together, right? In this picture, I don't know if you can kind of see the trees at the bottom, how it's curved. That's usually a good sign. If you're out somewhere and you see the bottom of the trees are curves, that's a sign that land is slowly moving down, right? Old gravestones tipped over, walls crumbling, right? The world is crumbling, right, all around us, and it's all up to us to just kind of like keep it all up. Curved bottoms of trees, right? See how that curved? Freezing and thawing patterns can do a very similar thing, right? Looks kind of like this, like you could kind of see it's all kind of like slowly moving downhill. Slumps, similar thing. Again, this could happen in bursts of time quite quickly. It could happen slowly too. Of course, it's much more noticeable. It happens quickly because the vegetation hasn't grown back, so you can see kind of the open areas. Again, places that have been deforested, or if you're overbuilding, kind of overtaxing the landscape, you can kind of make these things happen. Another good example of a real big landslide, right? It's like, sometimes a whole neighborhood can go. Debris flows. Oh, yeah. Now, I don't think this is an avalanche, or maybe it's a mixture. Volcanic ash mixed in can also make it all, if it's knocked down a whole forest of trees with a volcanic explosion, when those all kind of rot, that could all be washed down. But the debris from a volcano, when it's gone to where it's been washed down to, it can kind of solidify like rock, really hard to dig out of. Debris flow. Larger mass movements, you could kind of see where there had been landscape that broke off at a certain point in time. Types of avalanches. Rock falls. Some examples. Now these big boulders in Yellowstone, are they rock falls or are they erratics? It really depends. Erratics are things that were pushed by the glaciers and then just kind of left in place after the glaciers receded. Lots of landscapes are made with glaciers, especially northern climates. Even of course, obviously, if there's not a glacier there today. Talus cones, these are just like rocks being slowly dissolved from the mountains and falling down, create these little cones. Mass movement, again, mass movements, very expensive, obviously, right? Map of deadly mass movements. Well, if you look at these and their placement, a lot of mountains, right? Well, in the mountains where snow and rock cling to impossible angles, the smallest tremor can trigger an avalanche, a roaring river of air and stone. When it stops, the debris fans out below, forming talus cones at the foot of cliffs. These are the archives of collapse. This is what we look at to figure out what happened. Each fragment is a record of 1,000 freezes and thaws. Gravity, again, doing its slow, certain work. Causes of deadly mass movements. Well, this is, we come to the human story. Well, when we build on slopes, right, when we deforest hillsides, we cut roads through mountains, and then we act surprised when the land remembers its own agenda, right? Around the world, millions live in the shadow of gravity's patience. Satellites now map that risk. Data from orbiting warning for the next collapse, but ancient forces remain the same. Water, rock, and time, old collaborators conspire quietly beneath our feet. Global landslide risk map. From the highest peak to the lowest delta, the Earth is forever remaking itself, weathering, erosion, death and rebirth in mineral form. All right, what we call a landscape is all but a fleeting moment in that grand process. The mountains crumble, the sand drifts, and one day, even this too will be gone, leaving behind perhaps just a faint impression of human hands that, once thought they could outlast stone. Map of potential areas. You got a lot of erosion. Mountains, this is also where you have the monsoon rain, right? So annual huge rains. Different types of mass wasting. Not going to go through every single one. Oh, but that's it.